electric charges and fields, chapter number 1, right? So today we are going for the introduction level only, not the numericals level. So what are the objectives? What are the points we have to learn in this chapter? First, electric charges and fields, then conservation of charge. Conservation of charge. Charge is conservation of energy, conservation of matter, all we have learned, right? Same way, conservation of energy we have to learn. Then Coulomb's law of force between 2 points charges. Very important for the numerical levels. Coulomb's law. Then forces between multiple charges, more than 2 charges. Then how we can apply Coulomb's law. Superposition principle and continuous charge distribution. Then we have to learn electric field, like magnetic field. If there is a charge, there will be electric field around that. Then electric field due to a point charge, and electric field lines, like magnetic field we have learned in the 10th standard. Around the charge there will be magnetic field will be there, field lines will be there, that we have to learn. Then the term electric dipole, it's a new term we didn't learn in the 10th grade, electric dipole. Then electric field due to a dipole. Okay. Torque on a dipole in uniform electric field. We are keeping the dipole in a uniform electric field. How the torque, turning effect takes place. Then electric flux. Then Gauss's theorem and its application to find field due to infinitely long straight wire. Uniformly charged infinite plane sheet. Uniformly charged thin spherical shell, inside, outside. These are the main topics what we have to discuss in this chapter. Okay. Today we are going on for the basic level. Why? Sometimes we can hear a crackle when we take off our synthetic clothes or sweater, particularly in dry weather, etc. Some kind of cracking sound we can hear. Okay. Mainly in the case of polyester sarees, we are going to textiles and sarees are one over other stacking. You take one, we can experience that. Some kind of cracking, some sound we can hear, that crackle sound. Okay. What is the reason for this one? Have you ever tried to find any explanation for this phenomenon? What is the reason? This is due to electric discharge. Electric discharge. You know electricity, right? How for this non-conducting material has electric discharge? It is there. That is what we are going to discuss in this chapter. Okay. Lightning is an electric discharge. Lightning, thunderstorm is everyone knows that. It is a common example of electric discharge. During thunderstorm, we can see the lightning. So what is happening? What is happening? Due to the friction of clouds, charges are accumulating in the cloud. That charge, when it's reaching to a high level, like lakhs of potential difference are coming. Such a high voltage is accumulated, charges is accumulated in the cloud. What will happen? It will force to discharge. Normally, air is a non-conductor, right? You cannot, the electricity will not flow through the air, non-conductor. But forcefully, it will ionize the air particles, and that will flow to the earth. Okay. Why it is flowing to earth? Earth is an electron bank. It can receive as many electrons. It can donate as many electrons. Earth is a electron bank, right? Can receive and donate. We can give. So that phenomena is actually lightning. Okay. So our point of view, it is a electric discharge. Now, shock from doorknob. If you are just opening the door, you are just rotating the knob, sometime we may experience a kind of shock. We will take the hand immediately back. Okay, some kind of shock. What is the reason behind this? The reason for these experiences is discharge of electric charges through our body, which were accumulated due to rubbing of insulating surfaces. So, on the doorknob, but somehow charges are accumulated. Maybe different people are coming and opening and closing. So some charges are accumulated due to continuous friction. Okay, charges accumulate, and we are also coming. We are also touching these and that carpets, different materials. So our hands is also getting rubbed with different objects, right? Friction is taking place. So there are charges accumulated in our hand also. So when you are coming and touching the doorknob, what is happening? Electric discharge is taking place. Okay, that is the feeling what we are getting, a shock. See, here on the doorknob you can see, right? The charges are there. So on the doorknob, positive charges. Okay, and our hand, negative charges. Okay. So when we are coming and touching, electric discharge is taking place. Okay. So that is giving you a shock or spark. Okay. Got it?
Yes, sir.
Fine. Now, static electricity. So this is actually because of static electricity. Electricity we can divide into two categories. One is static electricity, other one is current electricity. What is the difference between these two? Current electricity means current flow, continuous flow is there through a conducting wire or something. Devices, the electrons, the charges are flowing continuously. That is coming under current electricity. Static electricity means it is taking place in insulators. Okay, from one, the charges are not continuously flowing, but from the surface of one insulator, it is just transferring to another insulators. Okay, it is not a continuous flow. It is from one object, the charge is transferring to another object. Such cases we are calling as static electricity. Static means stationary. Stationary electric charges when moving from one object to another, that is coming under this category. Okay. So all these phenomena are due to generation of static electricity. We have just seen a lot of phenomena, right? On the doorknob, lightning, and even if you are using a scale and ruler, just to rub our hair, dry hair several times, just rub it and bring to small pieces of bit of peppers. You can see that pepper pieces are coming and attracting to this scale or eraser which is rubbed on dry hair, right? You can do yourself and see that experiment. So all this phenomena is due to electric discharge. So electric discharge is because of static electricity. So static means anything that does not move or change with time. Okay. Static, stationary. So electrostatics, or chapter electrostatics, deals with the study of forces, fields and potential arising from static charges. So static charges are the, so what are the forces between the charges, how the electric fields are generating, and how the potentials are arising from static charges. Okay. So potential, all this we have learned in the 10th standard also in electricity, right? The work done to move one unit charge, right, from one point to another, it is potential difference. If you are bringing it from infinity, then we are saying it potential. Okay. In details we will learn this later. Electric charge, some history. Historically, The credit of discovery of the fact that amber rubbed with wool or silk cloth attracts light objects goes to Thales of Miletus, the Greece guy around 600 BC. So, amber is a kind of a rubber. It is rubbed with wool or silk cloths, and when it is bringing near to light objects, it will be attracted. Okay, so this phenomena has been observed by Thales. Okay, so that credit goes to him. Is the guy's face. Now, the name electricity is coined from the Greek word electron, meaning amber. So this phenomena they observed in the case of amber. Okay, and in Greek, electron is the word for amber. Okay. So from that, the term electricity is derived. Many such pairs of materials were known, which on rubbing could attract light objects like straw, pith balls, and bits of paper, etc. See, we have a comb. To use a comb, and several times, if you rub on our dry hair and bring two pieces of papers, you can see that it is attracting. It will attract the small pieces of papers. This is because of charges. See, here we have negative charge, positive charge. When they are coming nearby, they are attracting, right? Like charges repel. Unlike charges, positive and negative attract. Fine. Now, attraction and repulsion of charges. Attraction and repulsion of charges. Two glass rods rubbed with silk cloths are brought close to each other will repel each other. Okay. Now we have two glass rods. We are rubbing these two glass rods with silk cloth. Okay, so two glass rods, same material, right? Same material. It is rubbing with silk cloth. So this both will get same charges. This and this are getting same charges, right? It will get same charge, right? Because they are both same material glass rods. So when these objects which is getting same charges, see, we have a glass rod here. One glass rod is now suspended with a silk thread, okay, for the experiment purpose. Okay, this glass rod and this glass rod we have rubbed with silk cloth. So what happened? Both has got same charges. So when you are bringing this glass rod, one of the glass rod, near to this freely suspended glass rod, what is happening? It will go away. It is repelled. When this is bringing near to this one, this is going away. It means it is repelling. Okay. So from this we can conclude that same charges, like charges, experimentally we can conclude that like charges, what will happen to like charges? They will repel. They will repel. Right? Similarly, two rubber rods, plastic or ebonite rubber rod, rubbed with wool. We are rubbing it with wool and two rubber. Okay. So with these two rubbers, when you are rubbing with wool, what will happen? These two rubbers will get same charge. Correct? So when you are bringing these two rubber rods which are rubbed with wool, bringing nearby, they will repel. They will also repel. See here, the second case. This is a rubber or plastic. Rubber, plastic has same property. This is the rubber or plastic. Okay, so this is another one. Okay, same material. One is freely suspended of using a silk thread, and we are rubbing this both same material using a wool. So what is happening? They are getting charged. They are getting same charge. So when this freely suspended plastic rod or rubber rod near to that, when we are bringing this charged plastic rod or rubber, what will happen? This will go away. See, this is going away. What is the reason? We can conclude that same charges, like charges, repel. Like charges, repel. Experimentally, we found that. Okay. On other hand, here we have glass. This is glass actually. This rod is glass. This is glass rod. And this is plastic rod, rubber. Okay, so it is a different material. So glass rod is rubbed with silk cloth, and this plastic rubber rod rubbed with wool. Okay, and they are getting different charges, unlike charges. One is rubbed with silk, another one is rubbed with wool. One is glass, another one is rubber. Glass and rubber. So when we are bringing this freely suspended glass rod near to that, when you are bringing this plastic rod, what is happening? See, this freely suspended glass rod is coming close to this one. It means they are attracting. So from this we can conclude that experimentally, unlike charges, what will happen? Unlike charges, attract.
Unlike charges are attracted.
Clear? So experimentally we found these cases. Okay? Experimentally we found this. So glass and rubber, they are attracting. If glass and glass, they are repelling. If rubber and rubber, plastic and plastic, they are repelling. Okay? Fine. So the glass rod and rubber attract each other in this case. Fine. Now, another experiment for the electric charge. If a plastic rod rubbed with fur, okay, plastic rod, rubber, it is rubbed with fur, some kind of wool, made to touch two small pith balls, or now we can write polystyrene balls also. Both are same. So we have a suspending facility, and we have a pith ball here, and here another pith ball here. Okay. Two pith balls are here. So freely suspended. Okay. Pith balls are freely suspended using some mechanism. What we are doing? We are bringing a plastic rod we are bringing, which is rubbed with fur. Okay. So we have a plastic rod. We rubbed with fur. So this plastic rod got a charge. Let it be negative. Okay, let it be negative. So when you are touching this charged plastic rod on the pith ball, what will happen? Some of the charge will be transferred to the pith ball, because pith ball was neutral. Neutral means what? No charge. Actually, all these materials are made up of atoms, right? Atoms are molecules. Fundamental particle is atom. Atom consists of what? Atom consists of?
Charges.
Atom consists of a small nucleus, right?
Yeah, nucleus.
And around the nucleus we have differential. So we know inside the nucleus we have proton and neutron. Proton is positively charged. Neutron is neutral charge, no charge. And around in different orbital, electrons are running and dancing and jumping, all this, right? They are moving here and there, right? First orbit, in chemistry we have learned, first orbit there will be 2 electrons, and next orbit there will be 8 electrons, like that. There are some conditions are there in chemistry, how they are orbiting. Okay, so these protons are inside the nucleus, it is in the center. So positive proton, positive charges, normally positive charge cannot transfer from one atom to another because it is in the center, it cannot move outside. Okay, but the outwardmost electrons, here 2 electrons, then 8 electrons, then 1 or 2, like that, the electrons are there. So when the electrons are more far from the nucleus, these are loosely bounded electrons. So these loosely bounded electrons can move from one atom to another atom easily. Okay. So when we are bringing this negatively charged object and touching on the pith bowl was actually neutral before number of protons. Here normally an atom means atoms are neutral. 9th standard we have learned. Suppose we have 10 proton, then there will be 10 electron also. 10 proton means what? 10 positive charge, 10 positive charge, and there will be 10 electron also normally. So 10 negative charge, overall it will be 0. Overall it will be 0, it means neutral. Clear? An atom will be normally neutral. But here using by friction, by rubbing, what is happening? They forced to transfer some electron from one atom to another atom or one material to another material because they are loosely bounded. They are loosely bounded. So these loosely bounded electrons, due to that charge now when you are bringing this near to this pith pole will become negative. This also will become negative. When you are then bring this and touch this pith pole also, so this also will become negative. So what will happen? Negative, negative, repel each other. See, this will go in this direction and this will go in this direction. Negative and negative are getting repelling. Understood? In second case, what they are saying? Okay, was suspended by silk or nylon thread, then they repel each other. Fine. That's the first case. Second case. See, pith bowls are touched with a glass rod, rubbed with a silk, glass rod. So we are bringing glass rod that is rubbed with silk. So what is happening? Glass rod, when rubbing with silk, these glass rods are getting positive charge. We will learn why they are getting positive, why they are getting negative. Okay, don't worry. So this glass rod is positive and bringing and freely suspended. Before these were like this, right? Maybe this is like this, and here also pith bowl, right? Pith bowl, they are very close like this. Fine, initially. Now when touching this pith bowl with positively charged glass rod, this will become positive. Similarly, this also will become positive. Both are getting positive. Okay, then what will happen? Positive will ripple. This will go to this direction and this will go to this direction. Ripple, right? Like charges, ripple, positive, ripple, negative, ripple. On other hand, see, a pith bowl touched with a glass rod attracts another pith bowl touched with plastic rod. So in this case, what is happening? In this case, we are bringing plastic rod which is charged negative to touch this pith bowl. So this will become negative. Okay. Another glass rod which is rubbed with silk. We are bringing glass rod rubbed with silk. Okay. Then touching this one. Then what will happen? This will become negative. Sorry, this will become positive. Positive touching here means some electron will transfer from this pith bowl to this one. So this will become positive. So one is negative and one is positive. What will happen? They are attracting each other. This will move to this side. More close it will come. So from this we can conclude that like charges repel, unlike charges attract. Unlike charges attract. Fine. Now, what are the conclusions from these observations? There were only two kinds of an entity which is called electric charge. The bodies like glass or plastic rods silk, fur and pith bolts are electrified. Electrified means they are getting charged. They acquire an electric charge on rubbing. While rubbing, one glass rod is rubbing with silk, they acquire electric charge. There are two kinds of electrification, and we find that one is like charges repel. Like charges repel. Another one is unlike charges attract. Unlike charges attract. The charges are transferred from the rod to the pith bolts on contact. So the accumulated charge can be transferred to another object, another neutral object, when they are coming in contact. Now, we have to just remember the terms electrification and polarity. Electrification means what? It is said that the pith bolts are electrified or are charged by contact. So when we are charging a material, that process we are calling as electrification, or we can say that is electrified. The property which differentiate the two kinds of charges is called the polarity of charge. So whenever we are saying polarity, it means we are talking about the charge, positive charge and negative charge. In chemistry, we will say it is a polar compound, right? It means what? It has charges, positive, negative charges are there. Fine. So if an object possesses an electric charge, it is said to be electrified or charged. Positive charge or negative charge, whatever it is, then we can say it is electrified or it is charged. When it has no charge, it is said to be neutral. Neutral. Okay? No charge. Now, what is positive and negative charge? These charges were named as positive and negative by the American scientist Benjamin Franklin. That credit also goes to people. Okay, so he called one of them as positive, other one as negative. So we have to follow the same system, no other option. Okay, so one of the charge is positive, one of the other one is negative. Okay. Then, by convention, the charge on glass rod or cast per volt is called positive. It's called positive. And on plastic rod or silk is termed as negative. I showed you before, right? When glass is dubbed with silk, glass, I told you it is positive. As a convention, it is taken like that. Okay, and plastic rod is rubbed. Then plastic rod got negative charge. Negative charge. So conventionally, we have agreed. Okay, these are the charges. Static electricity, frictional electricity. An examination point of view, you have to remember this definition. Memorize. Static electricity is an imbalance of electric charges within or on the surface of a material. The charge remains until it is able to move away by means of an electric current or electrical discharge. So normally when we are taking an atom, I told you number of protons will be equal to number of electrons, right? So that is balanced, right? So static electricity is an imbalance of electric charges. Some of the charges has been transferred from one atom to another atom, one material to another atom. So there is a imbalance. Then there will be charge will be accumulators. One will become positive, other one will become negative. Which one is positive? Which one will become positive? Which
charging
loses with the object which loses electron will become positive, right? Yeah. Which is gaining electron, that will become negative, right? Which lose electron positive, which gain electron negative, right? Fine. So the charges remain until it is able to move away by means of electric current or electric discharge. So if you are bringing that charged object and touching a pith bolt, so pith bolt also getting charges, so some kind of discharge will take place. Now, it is the electricity produced by rubbing two suitable bodies and transfer of electrons from one body to another. Okay. Fine. Now I have a question for you. Why glass becomes positively charged and silk becomes negatively charged on rubbing? When we are rubbing glass rod and silk cloth, I told you this glass rod becomes positive, silk becomes negative. What is the reason? What is the reason? That reason we are going to know.
Transfer of
Transferring. So why it is not ulta is not happening in the opposite side? Why the electrons are not transferring from silk to glass and silk become negative, silk become positive and glass become negative? Why it is not happening? What is the reason? Okay, that we are going to. Electrons in glass are loosely bound in it than the electrons in silk. Okay, so we have a nucleus. We have a nucleus. In the nucleus we have proton, right? Around that we have different orbitals. We have, right? We have different orbitals, right? So when the electrons are moving more far from the proton, positive charge. When the electrons are more far, it means they are loosely bounded, because this is a positive charge and this is negative charge. Positive and negative attract each other, right? So this attractive power is getting less when this is going more far. Suppose the electron is here, it is far, so the attractive is less. So when we are comparing the molecule or atom of glass and silk, we can say that the electrons of glass rods are loosely bounded when comparing with the silk atoms or molecules. So the preference is going for glass rod. Understood? Because it is loosely bounded than when we are comparing with silk. Okay, if you are using some other material with silk, maybe silk will be loosely bounded. So this is a comparison actually with respect to what other material we are using to rub. Okay, don't think that always electron will move from the silk will gain electron. No, it depends upon, right? If you are using other material which is more stronger, electron attraction is more stronger, then what will happen? Silk will give electron. But when we are comparing glass rod and silk, glass rod has a loosely bounded electrons. Okay, then that. So when glass rod and silk are rubbed together, the comparatively loosely bound electrons from glass get transferred to silk. As a result, glass becomes positively charged and silk becomes negatively charged. Okay. Similarly, why ebonite becomes negatively charged and fur becomes positively charged? We have an ebonite rod, plastic rod. When we are rubbing it with wool or animal fur, what is happening? Ebonite becomes negative, animal fur becomes positive. Ebonite is something, some kind of rubber. It's in the vulcanized rubber. Fine. What happened? What is the reason? Same reason, right? Electrons in fur are loosely bound in it than the electrons in ebonite. Okay. So what happened? So when ebonite and fur are rubbed together, the comparatively loosely bound electrons from fur get transferred to ebonite. As a result, ebonite becomes negatively charged and fur becomes positively charged. Understood? Ebonite becomes negatively charged and fur becomes positively charged. Okay, clear? Fine. Okay, so any doubts you can ask. We are going to stop the class today.